Hello, everybody. My name is Manos Tentzeris. Quite happy to be here for a second time, and also quite happy to have Paul giving the previous talk, because what I will show now is we're really close to the future, and we're really close to the point each and every one of you could literally print electronics, print your next cell phone, print your next sensor the moment you need it and how you need it. So what I will focus is on different aspects. First one, zero power. Everybody's complaining about batteries. How far are we of completely eliminating not only the cable, but also the batteries from your systems? And then how costly will it be? Can you bring it down to almost zero? And then the other question is, how complicated the system could be? Can you have a system like transformers? A system that will understand what's around it and optimize the performance by changing the shape. And that's what I mean about 4D printed. That's not only 3D, you have a fourth dimension, and this fourth dimension will be the shape. And then, where are we going to utilize this one? Is it going to be only for a niche of tech-savvy people, or is it going to be for everybody? Can you do it with just an inkjet printer? Can you do it with a 3D printer you can buy from Walmart, for example, and not a very expensive equipment like a clean room? And everybody's talking about different environments. You hear the term smart on everything here. You hear a term about smart cities, for example. So lots of communication, lots of sensing, smart agriculture, mobility, smart management, smart inventory, smart cars. In a sense, we're living in a very unique cosmos, as we call it. And what is cosmos? Well, cosmos used to be the Greek word for universe, but actually now we're living in a world of computational schemes for pretty much every object and system. Every object will have an intelligence. I mean, look at an everyday room, a regular house. Where could we add some intelligence? Fabrics. Could the fabrics monitor temperature, humidity, presence of bad chemicals here? Could your food package monitor itself and communicate with your cell phone saying, I've gone bad, please throw them away? Or you could keep them for another couple of weeks, past expiration date. You could talk about any device that will operate on every different object with any functionality you would care. And then you have the cars. There's lots of hype about autonomous cars, but also lots of reservation. Almost nobody trusts whether it's possible. And many times I keep on receiving questions, how far are we from a truly autonomous system? Not a system that will depend on weird shapes, very rare chargers, some limited range autonomy. So how far are we? And then the question is, how costly will it be? Can you have an autonomous car that will be cheaper than current cars and still safer? And if you think about this, you can see that requires lots of different devices. You need, in a sense, to have something we call the tricorder functionality. Anytime you're going to talk about the electronics of the future, you're not going to think only about the motion of electrons. You're not going to think only about the speed. You will need to keep in mind three things. Number one is going to be communication capabilities. Everybody wants to have more and more data. Everybody wants to have faster data, faster by 1, 2 orders of magnitude. You're talking about data needs increasing by a factor of 10, 100. Everybody's talking about wireless high-definition TV, possibly in seconds, and then different angles. And pretty soon, you're going to have virtual medical diagnostic systems. So for this, you need to have lots of data, but also you need to have this enabled by some energy harvesting system. Can you power it up utilizing your ambient energy? There's lots of wireless energy. There is lots of thermal energy, solar energy. Can you combine all of them? And we'll see some examples together. And then the other question has to do with mass scalability. Can you utilize the systems in billions or in tens of billions, or even trillions. I mean, pretty soon, and that's about IoT, United Nations have estimated by 2025 to 2027, for each and every living person on Earth, there will be 20 to 100 electronic sensors. So you are talking about trillions. And then the other question is, can you have systems that can monitor themselves? You know, if you have all these trillions electronics, you're not going to keep on checking them. You're not going to keep on changing batteries. Can you have a system that will check itself and tell you, hey, I'm broken, just replace me? And this one is exceptionally helped by the emergence of 5G networks. Again, there's lots of discussion about 5G, but why 5G is quite significant. Because if you look at this one here, you will see you can connect 10 to 100 times more devices, and also you look at a number called latency. Now, what's an application, what's an everyday application that latency is very important? Driving a car. That's the difference between having an accident or escaping an accident. And the major issue with most of the current systems for autonomous cars is that there is quite a significant latency, warning you. Now, with 5G and possibly 6G coming maybe within the next 5 to 10 years, latency will be even better than the human reaction. And that means we're having a quantum leap. We're having a car, we're having a device that will enhance your safety. And that's the first step of having the adoption that Paul was talking before. And then on the other side, look at these printers. I mean, that's an inkjet printer, and that's a 3D printer. You can buy this 3D printer from any shop like Walmart, Best Buy, for about $200 to $300. And then inkjet printer. Everybody's familiar with inkjet printers. Look what you can do. These are already existing prototypes for only the last, I would say, 3 to 5 years. You have, for the first time, some device. You have an IC that has an antenna on this. So now, theoretically, a computer size is limited by just the size of the IC you're using. You do not need to have big breadboards. You do not need to have big packages. You do not need to have any expensive devices. You just print an antenna on top of your IC. This one communicates to the neighboring IC, possibly next to each other, on top of each other. And not only that, but also you can have this in some stretchable or twistable configuration. Right now, there's lots of discussion about the new generation of devices. How are you going to adopt it? Sometimes the really big, bulky computers, big, bulky modules are quite difficult to wear, quite difficult to integrate with your houses, and so on. But if you have something conformal, something twistable, what can you do? You can very easily integrate it on a wall. You can easily integrate it around your arm. And that's now you start having the first truly wearable, the first truly implantable systems. You can also see another idea that has come very recently for smart hospitals and then smart agriculture. That's called backscattering. Typically, whenever we are thinking of communication, we're thinking of some big tower, big base tower. You just transmit some signal, maybe base station, to your cell phone processes that, sends some response to your base station. This one used to be a great system whenever you had a limited number of cell phones or devices. But now the question is, can you utilize existing systems, like a nearby music station, hitting your phone, and then respond to some gateway? So if you exist different stray signals around you, that will enable the reading of your sensors. Then you have zero power. You don't need to have a transmitter. You are utilizing signals around you, but not a dedicated transmitter. So much less power. Second one, you can also start thinking about all the electronics you are holding on your hands. You have remotes, you have smartphones, you have a laptop and so on that produce radiation. And that's quite significant. So why not having wearable sensors? Pretty much harvesting the energy of your handheld system and then retransmit to a Wi-Fi system at your home. Again, You don't have cables, you're not going to have batteries, the sensors will be truly wearable, truly flexible, not intrusive, not at all. Or you could have UAVs. And then that's where I believe we're getting in right now. Everybody's talking about the Internet of Things, but in reality, having all these printing technologies will move something I call the Internet of Smart Skins. So no matter whether you're going to have some smart wallpaper covering all the walls, covering all the floors, being integrated with your fabrics, being integrated with your car, being integrated with some agricultural domains, maybe next to a tree, next to some vegetable, and so on, or in chemical plants, you are going to have smart skins. Skins that will be able to harvest the energy from the environment and then operate pretty much with zero power. We are talking about maybe 20 microwatts, which is 20 millionths of a watt. Just to put in a perspective, whenever you have your cell phone, you are talking about a fraction of a watt. So now you are talking about almost zero power. And then how about the range? Because sometimes I keep on getting the question, if you have these batteryless systems, are they going to have a range of like 1 meter, 2 meters? How practical are they? And the answer is they're extremely practical. You have like 250 meters, 1 kilometer, and still you are going to be localized, angular range, real time. And then you see some of the first fully printed electronics, some systems that people like you downloaded the schematics for their 3D printer, and then they printed them. This is one 5G module that could emulate a 5G phone. That's on the top, 28 gigahertz. The other one at the bottom, it's pretty much a system in an antenna. So pretty much, this one is the ultimate satellite TV system. You're not going to have a big parabolic dish. You're not going to have any complicated system. You integrate everything within the antenna. And then you can also have self-diagnostics. Here, that's something I call. A big question is about counterfeiting. And that's sometimes a matter of life or death whenever you have life monitoring sensors or whenever you have aircraft safety sensors. You know what's going on with all these Boeing aircraft. There's a big question about this. But now if you have self-monitoring sensors, you can resolve this. And then now we're getting into the 4D printing, this transformer idea. So can you utilize an origami principle, allowing all of these devices to reconfigure their shape by just folding in different ways? So you could have a system like your cell phone that works perfect in one environment, and then you place it next to a bottle of water, or you place it next to some metal. It will go from 5 bars to 1 or 0 bars, straightforward. The question is, can the shape of your cell phone or can the shape of your sensor change as a function of time, utilizing origami principles, and then come up with a new shape, a new shell that will operate for virtually any environment? And we're not that far away from this. We're getting there. Just utilizing simple 3D printing or inkjet printing and then folding in different ways. The only thing you have to do is activate different hinges. And you can come up with shells or devices with unlimited shape selections. One possibly criteria to change their shape would be performance. The other would be what you like. So possibly, today you like some device, you like a phone, like a clamshell in the 2000s. And then after 5 years, you say, that's very boring. So what should I do? Reconfigure it. And then this one brings an enhanced perception. So now you're going to have the capability not only to fabricate your own electronics, but also do it the way you want to do, and not the way that's given uniformly by major electronics industry. You will have the freedom to do it as you wish without degradation of the performance. And then you can see like different shapes you can come up. I mean, you can come up with a single sheet pretty much to a triangle. Or you could have this cube there. You print it fully flat, and then it folds itself in a cube, and then it unfolds again to a flat configuration. Or as I show like at the bottom right, this is called an origami tree, where you're going to utilize for agriculture. This is kind of a trunk, origami folding trunk. Then you have different sensors, can monitor Minerals can monitor humidity, especially in the environment changes we're facing now. Water will be very scarce. Sensing is going to be very important. And then we'll go to zero power. Zero power means harvesting energy from the environment. And you can see here a very generic schematic of different forms of energy. Not only solar cells, but you could have wireless signals, you could have different heat, you could have different humidity, you could have different chemicals as well. And then you can see already existing systems here. So you can see that you can turn on this LED, for example, by just printing this harvester. You can communicate at the bottom left with some system by just utilizing ambient FM or ambient TV signals. No signal, you don't need any battery. You just reutilize, you harvest some part of the energy around you. Or you can just create energy by just walking, as it is at the top right. And then that's an example of what happened in Tokyo. So you could even harvest energy from TV stations or FM stations at a distance of 6 miles, 10 miles, 30 miles, 70 kilometers in Scotland. There have been experiments. And then you can power up your electronics. Just print something that simple as it's shown in the middle, top. That's like the U-shape harvester. That's on paper. So you don't need to buy some expensive material. You can print on paper. You can print on wood. You can print on glass. And one idea would be to print this system on your windows. And then printing your system on your windows, and there are ways of having optically transparent conductors, then you can harvest tremendous amount of energy. So the more electronic systems, the more wireless systems IoT induces, the more energy you can harvest. And then the easier it's going to be to have truly autonomous smart cities, smart devices, and so on. And then not only that, but the question is, because that's another question. OK, that's a two-rosy store. But you need to know where the energy is coming from. Otherwise, you are missing it. So the major step that was taken over the last 2 years is now you can do it in an agnostic way. So you don't know where the energy will come for any given time of the day. Maybe it's changing. I mean, lots of TV stations turn on the transmitters for 4 hours at night, so you cannot harvest UHF energy, but you can harvest FM and so on. So there are systems that have started showing up, such as the one at the bottom left, that can selectively harvest energy from the strongest direction without requiring anything from you. You just print it on paper, use it as a sticker on your window or as a sticker at the wall, and it just works. So this way, you can create energy. And also, you can store it. You can see like printable storage device, printable batteries, printable capacitor, and so on. And then look at all these sensors. Most of the people tend to think that sensors are very complicated. I mean, if you look at this is just 2 spirals. The top left, 2 spirals, and you can do pretty much blood test on yourself. You just print it on plastic, you just print the 2 spirals, and then you can do automatic blood test. And then at the top right, where you see this pretty much interdigitated system, you can detect carbon monoxide, you can detect benzol or dangerous VOCs or industrial chemicals. You can even have the food package tell you, hey, I'm bad. I'm sitting here at the supermarket, but freezing has not been sufficient. Now I have methane. Please throw me away. And I have a couple more slides just to show. One is this one. That's paper-based, comprehensive health analysis of bioliquids. So it could be your sweat. You want to figure out whether you get tired or whether you have diabetes and so on. You can just print it on this smart Band-Aid. Everything is printed here. You have like 6 sensors, and you can monitor anything from glucose to different minerals, calcium, so on, very instantly and very wirelessly. Just a sticker, just a smart Band-Aid. And the same thing that's for agriculture. So you can see here an agricultural sensor how small it is. You just have a leaf wetness sensor, soil moisture sensor, everything on paper. Monopole antenna, and then this antenna, you see this S shape, makes the system operate just utilizing the local TV station energy. So there's no battery here. Typically, whenever you're trying to do agriculture, you cannot have batteries because you have water and then bad weather conditions. This one is done automatically. And that's how you can make now sensors, as we call, like smart noses. So you can monitor just by a sticker like this at the top right. Temperature, humidity, ammonia, chemicals, and all of this. And you can do it for health monitoring by just dressing a bridge, a wind turbine, a fuselage, just print stickers. You're printing. You want to monitor whether your house has been infested by termites. Stickers around your house, monitoring chemicals, you can detect it as well. And I will close with this one, because that's kind of a fun project by some undergraduate team. That's something we call like the smart floating ball. And that's something we created. Pretty much it's a sphere. It's a small ball, like a golf ball. And then you have electronics there and can monitor the quality of water in real time. Can monitor whether there has been some contamination by drugs from some nearby chemicals. And you just transmit the data to your cell phone because you have printed this. As a conclusion, we're now at a very critical breakthrough point. And this breakthrough has been enabled by the convergence of something we call the perfect technological storm. So additive manufacturing, extremely low cost, everybody can do it. Energy harvesting, that enables you to eliminate batteries. Shape changing, so intelligence in the first transformers generation. And at the end, you also have the digital age, where everything has a digital signature. Doing all that along this 5G, 6G communications is a quantum leap. We're getting really close to the point that each one of you will just download the digital circuitry or digital schematic of what we want to print. You will just tweak it the way you want to do it, send it to your 3D printer or inkjet printer, and that will work. It will work for environments from cars to houses to wearables, on everything. And then people will start thinking about augmented reality applications. I believe we have just seen only the tip of the iceberg for augmented reality, because virtual reality, augmented reality, all of them, even the 3D TV, were too early, because the systems that would help you experience them were too bulky or too non-practical. Now we're moving to systems that will be so unobtrusive, like smart strips, that everybody can print, everybody can utilize. With this, I would like to close. Thanks for your attention.